Hi there, in this video we're going to discuss the normal distributions, and this is section 6.1 and 6.2 of our textbook. So we're going to look at the standard normal distribution. In the past chapter we looked at binomial and the Poisson distribution. Now we move on to the normal distribution. And we're going to be finding z-scores as well. So the standard normal distribution, which is a specific normal distribution having the following properties. The graph of the standard normal is bell-shaped, the mean is 0, and the standard deviation is equal to 1. The other thing that is important about the normal distribution is that the mean, median, and the mode are all the same. The total area under the curve is equal to 1, and again this is because this is representing the probability distribution, and in the previous chapter we discussed how the sum of all the probability distributions is 1, so the area under the curve represents the total probability. And then between mu minus 1 standard deviation and mu plus another standard deviation, we have the inflection points. So looking at this graph here, that's where the curve, this is the bell-shaped curve, this is where it starts to curve downward. So as you see it change from, this is curving up, and then right at that point it switches to curving downward, and then here's curving down, and then it switches to curving up again. So the curvature changes. Those are called inflection points, and where this happens is where we essentially have one standard deviation away from the mean, either to the right or one standard deviation to the left. So this is a good way, being able to identify where those inflection points are gives us a good way of approximating what our standard deviation will be. So a normal distribution can have any mean and any positive standard deviation. These two parameters determine the shape of the normal curve. Now, when the mean is 0 and the standard deviation is 1, that's when we have what we call the standard normal curve. So let's look at some examples. Estimate the mean and standard deviation of this normal distribution. So these are not standard normal because the means are different. They're not 0. So for graph A, what would you say the mean is? So graph A is the tall one. So it looks like the mean is, the mean is right in the middle. So it looks like it is at 15. So I will say that the mean here is 15. And what about the standard deviation? Now the standard deviation, as we discussed up here, is one standard deviation is where that inflection happens, where the curvature changes. So essentially you're looking at the curve, and then you see, okay, right around there it looks like it's changing. So that is close to 18. You could probably, since we're just estimating, you could probably say that it does happen at 18. It appears to happen a little bit less than that. So I'm just going to say that the standard deviation, my estimate is going to be that it's 2.8. If you said it's 3, that's fine. We're just estimating here. Now, what about B? B, the mean seems to be, that's the tallest portion of the graph, the middle of the bell shape. So that appears to be 12. And what about the standard deviation? What would you say it is? Notice that where it changes curvature is, now it looks like it's right about 18. Oh wait, I'm looking at the wrong graph, aren't I? So maybe based on that we can change that to 3. But here, let's looking at this one, well, I guess it does still appear to be right around 18. So the distance between 12 and 18 will be 6. So I will say that the standard deviation then here is 6. So the larger the standard deviation, the more spread out the graph is. And the smaller the standard deviation, the more narrow your curve will be. So imagine if you were looking at test scores for any of your classes, right? You want the standard deviation to be small rather than between 2.8 and 6. I would rather have that 2.8 standard deviation, meaning that all the scores are pretty close together rather than a big spread like graph B. So the standard deviation helps tell us about the graph. The bigger the standard deviation, the more spread out the data. The smaller the standard deviation, the more close together the data is. Now, there are infinitely many normal distributions, so this is a really big point. And each with its own mean and standard deviation. The normal distribution with a mean of 0 and standard deviation of 1, that should say 1 there, is called the standard normal. Let me put in the 1 in there. All right, just make sure that you add that into your notes. Standard deviation of 1. So mean of 0 and standard deviation of 1 is called the standard normal distribution. The horizontal scale of this distribution corresponds to z-scores. Remember, we studied z-scores before. The z-score is any data value x gives you the distance away from the mean. So we can find it for any data value by giving the data value minus the mean divided by the standard deviation. So x, or whatever data value, minus the mean divided by the standard deviation. So that tells us how far away we are from the mean. So with the standard normal, the mean is 0 and the standard deviation is 1. So each of these numbers represent how far away from 0 you are, which because the standard deviation is 1, you just see 1, 2, 3. If the z-score is negative, the data value is below the mean. And if the z-score is positive, the data value is above the mean. The area under the normal curve corresponds to the probability of data values occurring. So the total area under the curve is 1, which is the total probability. So for example, here, right, the area, when we have a z-score of 0, or in order to get the mean, what is the probability of getting the mean? The probability of getting the mean will be 1/2 because the mean is right in the middle of the data. So you have the area to the left of the mean will be half. So the probability of getting exactly 0 will be 1/2. Now, using the standard normal distribution, you will be able to calculate the area under the curve corresponding to any z-score. And there are multiple ways to do this. In this class, we will use the ones that we will use the most will be the standard normal table in the back of your book and StatCrunch. Other ways that you can find z-scores are, well, table A2, that's the one we will be using. You can use StatDisk, you can use Minitab. I haven't really talked about how to use those. You can use Excel and StatCrunch. So the ones that we'll be using in this class that I will show you how to use are the table. So table A2, and I will show you how to find that. I guess maybe yellow is not the best highlighter to use on yellow. And StatCrunch. So these are the ones that we'll be using the most. And in order to find areas in between two boundaries, StatCrunch is the one that does a better job than the table. I'll still show you how to do it with the table, but we'll rely on StatCrunch to do that. So let's try some examples. Find the area, and remember, area is the same thing as the probability of the indicated region under the standard normal curve. So to the left of z equals negative 1.23. So I kind of gave this the standard normal with their particular z-scores. So where does negative 1.23 land? So negative 1.23 is just to the left here of negative 1. So let's say negative 1.23 is right there. So since we want the area to the left, so that means we want this area. So how do we find that? And so we're going to go to the book, and we're going to find the probability that z is less than negative 1.23. And so let me take you to, I'm going to use the ebook. If you have the physical copy of the book, then you can do that through the book as well. So when you are on our homepage, you will see the, where is that? My Lab in Mastering. And you will go to open My Lab in Mastering. And so here it is. And so we're going to go to the e-text. and open the eText. Once you are in the ebook, we're going to go to the table of contents and then scroll all the way to the bottom. And notice that we have z-scores and t-values way at the bottom, so right underneath index. So make sure that you are on the table of contents and go all the way to the bottom for z-scores and t-values. And so click on that and our z-scores will show up. Now I can close that and I have my z-scores. So what we want to find is the probability that z is less than 1.23. So we're going to find that z-score, and I'm going to show you how to do that using the table. So notice that the graph here already tells you that is giving us the area to the left of the z-score. So the way that this works is that you find z-scores are always going to be approximated to 2 decimal values. So the column gives us the value, the number value, the ones digit and the tenths digit. So the ones digit, the decimal point, and then the tenths digit. And then the row gives us the hundredth digit. So like for the one that's over here, negative 1.34, right? Then this will be negative 3.1, negative 3.40. And then if I go to the third column, that's 0.02, that will be negative 3.42. So what are we looking for? We're looking for the z-score of negative 1.23. So we're going to go back to our z-scores and look for negative 1.2. So here's negative 1.2, and then negative 1.20, negative 1.21, negative 1.22, negative 1.23. So this is the one that I want. So 0.1093. And so we'll go back to our notes and say then this probability is what we saw from our C table. So it was 0.1093. Now let's try it for the next one. So to the left of z equals 2.04. So where is 2.04? So that's going to be just barely over z equals 2. And I want the area to the left. So that means we want all of this. So notice that now this probability should be really high, right? So because we almost have the entire thing. We almost have the entire bell shape, whereas here we have just a little bit of it. So this is about 10.93% of the data. That's the probability. Here we have almost the entire table, so I should expect that to be very high. So let's go to the table. And notice that this is giving me just negative z-scores. So, and it does tell me here negative z-scores. So go to the next page. So click on the next arrow. And now notice I have positive z-scores. Pay attention to the graph. It still says z and the left is shaded. So it is still giving me the area to the left. If you're Googling z-scores, z-tables online, pay attention to this graph because sometimes there are some that will give you the area to the right instead of the left, but there will always be a graph like this showing you, indicating the shading, which is giving you, which area is it giving you, which probability. So what z-score were we looking for? We're looking for 2.04. So that means, and so let me kind of write out here what we're doing. So in the column part, we are going to be looking for the 2.0, right? The ones digit, the decimal, and then the tenth digit. And then on the row, we're going to be looking for the 0.04. And so where those two meet up, that is the value that we want. So let's go to the table. So I'm looking for 2.04. So I'm going to scroll down. My page for some reason doesn't show me the whole page, which is actually okay because I want it zoomed in. So 2.0, and then 0.04 is over here. So that's the 1, 2, 3, 4, the fifth column. So I'm going to go back to 2.0 and then 1, 2, 3, 4, 0.5. So 0.9793, which makes sense because we said we should expect it to be very high because it was most of the curve was shaded. So 2.04, 0.9793. So let's write that down before I forget. So it'll be 0.9793. So the probability that Z is less than 2.04 is 0.9793, which is 97.93%. Pretty high, which is what we expected based on the shading that we see. All right, let's try the next examples. Now we're going to do the same thing here. First, locate our z-score. So our z-score is 0.068, so really close to the mean. So 0.068, let's say somewhere over here. And so we want to shade the area. Now notice that it says to the right. So let's say 0.68 is over here. And so now we want the area to the right. Now this is where we're going to use the fact that the whole thing is equal to 1, right? So the area here, the whole thing is 1, and the z-score is giving us the area to the left. So that means that the area to the right is going to be 1 minus the probability that z is less than 0.68. Why is that? Because the z is always giving us the area to the left, and so we want to find the opposite side. So it's 1 minus whatever the area to the left is. So then the probability that z is greater than 0.68 is going to be 1 minus the probability that z is less than 0.68. One of these should have an equals. So let me do that. And so let's go to our table. So now when I look at, since it's positive, I'm going to go back over here. So 0.68, so 0.6, and then find the 8. So 0.68 is the one before the last. So let me make sure again. So 0.68, so 0.7517. So that's, notice the area to the left. So 0.7517. So I'm going to bring that back over here. So what I just found is that this area on the left is 0.7517. So the area to the left, that's what the table is giving me, but I want the area to the right. So then the probability that z is greater than 0.68 is equal to 1 minus the probability that we're less than 0.68. So 0.7517. And so do that on your calculator and see what you get. I got 0.2483. So that will be then the area to the right. Is 0.2483. In terms of probability, this will be 24.83% chance of getting a value over there on the right. Now for this one, to the right of z equals negative 1.57. So where is negative 1.57? So negative 1.57 is between negative 1 and negative 2. So somewhere over here, and we want the area to the right. So that means we still want this area to the right. So again, the z-score, when I look it up, it gives me the area to the left. So when I look up the z-score on the table, it's giving me the probability that z is less than, right, whatever my, in this case, negative 1.57. So that means that the area to the right is going to be, again, I'm going to have to do 1 minus the probability that z is less than negative 1.57. And so let's go to our table and find negative 1.5 on the columns, and then, or on the rows, and then 7 on the columns. So let's go to the table. And I'm on positive z-score, so I'm going to click on the back page to go to the negative z-scores, and we're looking for negative 1.5. So there it is, and then 7. So that's 0, 1, 2, 3, 4, 5, 6. So that's 7.0582. Now again, this is giving me the area to the left. So I want the area to the right, so I'm going to do 1 minus this. So 0.0582. And then put that in your calculator and see what we get. And notice that it should be a pretty high value because we have a lot of the curve shaded. Right? We have all this stuff. Most of the curve is shaded, so we should expect it to be a pretty high value. So the area to the right of our z-score, which was negative 1.57, is 1 minus that, which I got 0.9418. And so let's try. So hopefully this is making sense. So looking at the table, and then I'll show you how to do it in StatCrunch. So let's try the in-between ones, and then I'll show you how you can do it also in StatCrunch. Now for these ones, we want to do between 0.45 and 1.96. So 0.45 is kind of in between 0 and 1, almost in between, right? And then 1.96 is really, really close to 2. So we want to find the area in between these two values. So that's the area that we want to find. So how do I find that? Well, if I look at the tables, the table is going to give me, if I look up 1.96 over here, right, then this is going to give me the area all to the left of 1.96. So I'm going to have a bunch of area for 1.96. And then I'm going to need to look up the 0.45. So let me see, how can I show you this better? All right, so what I'm going to do is we're going to find 1.96. So 1.96 is over here. And so when I look up the z-score for this, it's going to give me the area to the left of 1.96, right? But I don't want all of that. And then I'm going to look up the area for the z-score 0.45. So I'm going to go over here to 0.45. And when I look up the z-score for this, it's going to give me the area to the left. Right now, the area that I want is the one in between 0.45 and 1.96. So this is what we're going to do. We're just going to extend those lines and say, okay, so how do I get just that area? So hopefully you see what I'm about to do here. So what we're going to do is we're going to get the area for the z-score of 1.96. So we're going to get the probability that z is less than 1.96, and then we're going to subtract, right, because I want to take away this area so that I'm left with just the in between. So I'm going to take away that. So I'm going to take away the probability that z is less than 0.45. So I will look these up, both of these, on my table. So let's start with 1.96. So 1.96, I need to go back to my positives, z-scores, and let's look for 1.9 over here. So 1.9, and then 0, 1, 2, 3, 4, 5, 6. So 0.975. So this area is 0.9750, and then the probability that z is less than 0.45. So I'm going to look up 0.4 and then 5. So let's go back to our z-score. And so 0.4, and then there's 0, 1, 2, 3, 4, 5. 0.6736. And now subtract those. So that means that the area, so for the probability that 0.45, the z is between these two, now is the difference of those two. And so let's put that on our calculator and see what we get. I got 0.3014. So hopefully that's what you got as well. So this is the area in between. Now that took a lot of effort, right? So now on your own, try this one and see what you get. Do it on your own. So go ahead and pause this video and try to do the same thing that I did here. And to find the area between -1 and 0.75. And then I'll show you how to do it in StatCrunch. So go ahead, pause the video, do it by looking up the tables. When you unpause, I'm going to show you how to do it with StatCrunch and see if we get the same answer. All right, now that you've unpaused and you want to see how to do it in StatCrunch, we'll go back to our textbook, and actually we'll just go back one window over to my math lab, and instead of the e-text, we're going to go to StatCrunch. So we're going to open StatCrunch and just go to the StatCrunch website. So click on that. Don't worry about clicking on, let me log in real quick. Okay, so click open StatCrunch, and when you're at the menu for StatCrunch, sorry if the top is not showing, now we're going to go to Stat, just like what we did for the binomial in Poisson calculators. Go to Stat and then Calculators, and then we're going to look for normal. So go to normal. So when we did binomial, you will go to binomial here, normal. So click on normal, and it gives us the normal distribution, the standard normal. And so this gives me the standard. So like if I wanted to find like the one that we did earlier, the first one we did, that it was find the area to the left of z equals -1.23. So now I can do that and say -1.23 here and compute. And notice that we got the 0.1093 that we had gotten before. Now the nice thing about StatCrunch is that it also gives me the areas to the right. So when we were doing to the right of 0.68, I can just put 0.68 and compute, and it gives me that one, right? So then this one's a little bit nicer because then I don't have to do 1 minus. So with the table's always giving me the area to the left. With StatCrunch, you can choose if you want the area to the left or if you want the area to the right. So StatCrunch is pretty nice about that. And now switch to between, and notice that it gives us between two values. So now the one that we want to do is, well, the one that we just did, let's just check it. It was the area between 0.45 and 1.96. And click compute, and there it is, 0.30135. So we might be a little off just because we were rounding before using the table. And now the one that we want is the area between -1 and what's the top value, 0.75, and compute, and there it is. So notice that it even shades the table for us, or the graph. So the area is 0.61, usually round to 4 decimal places because that's what the textbook does. So we'll just do 0.6147 and take it back over here. And so that is the area here for this one. Is that what you got when you did it on your own? Hopefully. In your notes, you have these 2 other ones. Find probability, so that's still asking you for the area, z greater than -2.10. So try that now that you know how to use StatCrunch for finding normal probabilities. Try that on your own, and then try also the 0.41 z between those 2 values. So try those on your own and see what you get. Now, the big thing here is that we're trying to get to that any normal, non-standard normal distribution can become a standard normal distribution by converting it to the z-scores. And so I can find the z-score for this example. The mean of our normal distribution is 100 with a standard deviation of 15. Find the probability that x is greater than 120. So let's do it by finding z-scores, and then I'll show you how to do it also in StatCrunch without having to find the z-score. Now to find the z-score, right, remember that the z-score is C equals to the x value minus the mean divided by the standard deviation. So in this case, our x will be 120, the mean is 100, and the standard deviation is 15. So then this will be 120 minus 100 divided by 15. And so 20 over 15, and that reduces to 4/3, but we're going to use the decimal 1.33, and it repeats, right? So 1.333. So on our table, our z-score table, this is what we would look up. So we want, oh, my shading is different. We want the probability that x is greater than 120. So I should really have shaded the other way. So we want this probability. And so we will look up our z-tables for that. So we will look up 1.33. So 0.9082 will be the area for x graded. So this is giving me the less than, right? But I want greater than. So what was it again? 1.33, so 0.9082. So it will be the probability that z is greater than 1.33 is 1 minus the probability then that z is less than 1.33, which was 1 minus 0.9082. And so whatever that is, which I got 0.0918. So not very high. Now doing it in StatCrunch, let me go back to StatCrunch. That means that I will go over here and go back to standard. But now I don't have to do z-scores. I can just do my mean is 100, my standard deviation is 15, and I want the probability that x is greater than 120 and compute. And there it is, 0.0912. It's a little bit off because we were rounding before. I did 1.33. This StatCrunch is actually doing a lot more exact. So the nice thing about this is that then I don't really have to compute the z-score. I can just put in whatever my mean is, my standard deviation, and find whatever probabilities I need. Okay, so there's another example in your notes with the M&Ms. So go ahead and try that on your own. I'll record a video for the last of the few examples, and I'll post it also. But this is kind of the gist of everything. Contact me if you have any questions.